Hey there, y'all. Today we're going to look at 3.2 on domain and range. And so in this section, you're going to be able to identify the domain and range of relations and functions. And this continues in our FIF1 standard, and being able to understand that the function from one set, called the domain, to another set, the range, assigns to each element of the domain exactly one element of the range. And so let's talk about what is domain and range. And so domain is the complete set of input values. And the range is the complete set of output values. And so when we're talking about input values, remember we talk about that typically being our x values. And our range is typically the y values. And so what does that mean in the problems that we're going to look at? And so yes, in the previous video, in 3.1, we looked at different ways we can represent relations and functions. And so we're going to look at a lot of those same problems today, but instead of what we did in section 1 and talking about just what they represent, we're now going to talk about the domain and range of those examples. And I've thrown in a couple extra that we need to see. So let's look at first sets of ordered pairs. So as we look at this first example, what is the domain and range of the following? And so this is the same example 1a from the 3.1 video. And so we're given the order pairs -2, 4, -3, 5, 4, 6, -4, 6, and -6, 6. And so our domain is a list of all those x values. So -2, -3, -4, and -6. Now, we typically want to list them in numerical order, so we're actually going to flip this. And so -6, -4, -3, and -2. Now we'll also do our list for the range. And so the range is the y values. And so we've got 4, 5, and 6. Just like with mapping diagrams, we don't repeat values in domain and range. Okay? Let's look at example B. So 1, 1, 2, 2, 3, 3, and 3, 4. And again, we want to know what is the domain and range of this one. And so the domain, again, is the list of our x values. And we won't repeat any value that repeats. And so it's literally just 1, 2, 3. And for our range, we look at the y values, 1, 2, 3, and 4. That's it for domain and range. It's not hard when it comes to just listing out ordered pairs that we see. So now let's look at the next example. So as we look at example 2 here from a table, it's just like we did with the ordered pairs. We want to know what are the x values to our domain and what are our y values for the range. And so remember, we want this list going from least to greatest for both of them. And so -5, -4, -3, -2, and -1. And for the y values, 7, 8, 9, 10, and 11. Again, if we're just given a list here, like a table or a set of ordered pairs, we're just going to list out the specific values that we have. Now, when we look at other types of representations, we're going to talk about those in a minute. But first, let's look at those mapping diagrams that we looked at yesterday. So as we look at our mapping diagrams, again, it is still just a list of our x's and our y's, domain being x, range being y, right? And so remember, when we look at our bubbles for our mapping, they're already in order most times. Again, if you're doing what I've asked, then you have them already in order. But for the domain here, it's just these 4 values here. So 1, 2, 3, and 4. The range, 1, 4, and 9. That's it. Again, this isn't a hard topic when it comes to just listing the points. Okay? When we look at example B, the domain here, just our list of x, so 1 and 2. And for the range, 1, 2, 3, and 4. That's it. Again, when we're looking at ordered pairs, when we're looking at a table, when we're looking at a mapping diagram, we're just looking at the values that have been given to us. We're not going to add anything. We're not going to take anything off of those lists. We're going to use what we're given and just not repeat any values that happen to be repeated inside each of the individual ones. So like you see here, we have 1 and 2. It's down here as well because it was in our range. Okay? And so now let's look at what happens with graphs. And we've got a couple of graphs that we're going to look at on how we deal with domain and range with those. So as we look at this graph here for example A, we want to know what is the domain and range of it. Now, one thing to remember is that this line continues up here. There should be little arrowheads on each end of this graph. But what is the domain and range? And so we need to understand how far this will go. And we have a couple ways that this can be represented. Now, domain is dealing with x. So how far to the left does this go? And how far to the right does this go? Well, as this goes to the left, so as we're talking about this graph going further and further this way, right? It's going to go that way forever because this graph is going down, but it's also still going to the left. And so, hold on to that piece. Now let's talk about it going to the right. Well, this graph is also going to keep going to the right because this red line is going up, but it's also going to the right. And so it's going to go across all of our x values, which means that the domain is all real numbers. Now, there are other ways to write this. And another way that we can write this is what's called interval notation. Now, this is not something you have to get today and understand perfectly. But I want you to understand that this is something you're going to see more and more the higher you go up in algebra. And so interval notation, we said that this is going to go out to the left forever. Well, what's the furthest number to the left you can think of? Maybe negative a million, negative a billion, something, right? Well, it keeps going forever past that. And so the way we represent that is with negative infinity. Now, this is also going to go to the right forever. And so what are we going to do going to the right? It's going to be positive infinity. And we're going to show this interval notation when we deal with infinities with parentheses. And so this would be how we represent all real numbers in what we call interval notation. Okay? Let's look at the range. Well, what's the range do? How far down and how far up do our y's go? Well, they go down forever, right? But they also go up forever. And so what is our range of this? Again, it is all real numbers. And if I want to express that in interval notation, that would be from negative infinity to positive infinity. That's it for that one. Okay. So again, domain is how far left and how far right can this graph go in x. Range is how far down and how far up can this graph go in y. And if it's just a regular line, unless there's endpoints, it's all real numbers in both directions. All real numbers for the domain, all real numbers for the range. Let's look at example B and see what this graph's going to do. And so remember example B from yesterday was this circle graph. And so that doesn't go out to negative infinity and positive infinity in this case, right? And so what we have to look at is we can talk about how far left this will get. Well, the furthest left it gets is right here at what x value? At negative 5. And how far right does it get? Well, the furthest right it gets is positive 5. And so we have a couple different ways that we can represent this. The first is as an inequality. And we talked about compound inequalities at the end of Unit 2. And so this goes from where? Negative 5, less than or equal to, because we have a dot at negative 5. Well, there's a point at negative 5 anyways. We're dealing with the x values. Less than or equal to, because again, I can be this endpoint, and I'm at 5 on that side. Now, we talked about the interval notation in the last problem. How would I represent this in interval notation? Well, I'm going to have that negative 5 and 5, because that's my two furthest points left and right that this will go. But instead of having parentheses, we have to show that this will be less than or equal to. And that's represented with brackets for each end. And so instead of the parentheses that we used on the infinities, because there's not an endpoint, we use the brackets because the endpoints are included. All right, so what's the range? Range, we're going to do the same thing. We got to look at how far down on this graph we can go and how far up on this graph we can go. And so for the range, we see that it hits here at the negative 5, and it also hits here at the top at positive 5. And so it would be negative 5 less than or equal to, not x this time because we're dealing with range. Range is in y, and then less than or equal to positive 5. And then in interval notation, that is going to be the same that we had before, negative 5 to positive 5. Now again, if you don't understand the interval notation, what I need you to understand is how to write it in this inequality notation. Okay, let's look at the last example. What is the domain and range of this graph? And here we see a parabola. This is a quadratic function. And we want to talk about how far it goes from left to right, how far it goes from top to bottom. And so how far is this going to go left to right? Well, these will continue forever going up. But as they're going up, they're also going where? Out. And so what is the domain of this? The domain is all real numbers. Or in that interval notation, what's it going to be? We had this in problem A, negative infinity to positive infinity. Now the domain's a little bit more interesting because this goes up forever, right? But it doesn't go down forever. It stops. Where does it stop? Well, the very bottom of this graph is here at this y value. And that y value is negative 9. And so our y values are going to have to be above negative 9. It can be negative 9, but it also be above it. And so as an inequality, this is just y is greater than or equal to negative 9. Because the y values have to be greater than or equal to that value. Because it's going up, right? Now, in interval notation, this is how it's written. And in interval notation, we always go from least to greatest. So we're always going from small to big. And so in this case, we got the negative 9. But this is going up forever. So what's it going up to? Positive infinity. With the infinities, we always have that parenthesis. But this negative 9, we have the equal to part, so it has to be a bracket. Okay? That part's a little confusing when we first talk about it. But the more you work with this interval notation, the more you're going to like it. I promise you on this one. That's it for today. I hope you enjoy this video. Make sure you fill out your Google form, and I'll catch y'all next time.